Okay, for MOM, question 1.1, what and how the data will be acquired? What are the dependent and independent variable? The data that will be acquired is the settling time, response time, maximum overshoot, and steady state response of different type of controller. It will be performed through MATLAB Simulink. It is obtained by identifying the transfer function. To increase the rise time, a proportional is added. To reduce the overshoot, a derivative control is added. And to reduce the steady state error, an integral control is added. We will adjust the gain to get the desired output. The dependent variable is scope component in block diagram. It will display on the PID controller where we can obtain the value of transient response. The independent variable is step component. We can preset the value of initial and final value, sample time, and step time in the block parameter. Okay, next.
Okay, for 1.2, what and how the analysis will be conducted. Okay, for the step 1, we open a MATLAB and write a command at command window, open system SCD speed control PID block. And the step 2, a block diagram will appear and you can change the PID controller on your own task, P, PI, PID, and PD. And step 3, we need to try an error to get a better graph result. And step 4, we record the good graph result and value in PID to complete the task in 2.6. Stop present. Okay, 1.3.
Nampak kan? Nampak. For 1.3, we have to explain all the parameters that involved in this study. So in this study, we need to find the settling time, response time, maximum overshoot, and steady state response. So this is the parameters of the block that we choose. And then for this experiment, we have two methods to carry out. So first of all, it's trials and error. Trials and error method is the easiest method to find the best parameter for the PID. We can see the results for each parameter and pick the suitable parameter. Small values will be used first to see the improvement of the response. The P action is used to accelerate the response time. Oscillation is caused by exaggerated P action. The I action is used to get the necessary steady state response. The downside is that the oscillation direction is higher over a longer length of time, and the D action is used to dampen the sound. The drawback is that oscillation at a high frequency is more likely, as does susceptibility to noise. And the second method is Ziegler-Nichols. This method can only be used for stable processes. It is required to estimate the process characteristics of open loop tests. In PID, it can be used on closed loop tests. To get the estimate process characteristic, it needs to push the controller to its stability limits. Nampak? For 1.4, what are the expected result of the coming experiment? After tuning the PID controller, the engine speed control RPM will be fully stable. Each of the controller types are achieving zero steady state error or small change in value, and the settling time is under 5 seconds. Next. this is the answer for the question 1.5. This is the block diagram that we construct. Here we use speed reference, KID controller, throttle and manifold, induction to power stroke delay, combustion, drag torque, vehicle dynamic, radius to RPM, engines and engine speed. So finally we connect all of the components, we get the answer and we record the result and find out our value to make it in table. So that's all from us. Thank you.